Section 1-2, Day 1. We're going to be talking about transformations of functions, and we're talking about two functions in particular, the absolute value function and a quadratic function. Now, you learned both of these back in Algebra 1, so this is a review of vocab, graphing, etc. So let's talk about the parents first, because the parents are very important. So first of all, the quadratic parent. I'm not sure if you guys remember it from Algebra 1. If not, that's okay. The absolute value parent function is f of x equals x squared. And then the absolute value parent is f of x equals the absolute value of x. Now remember, parent function is the simplest form of the function. Is this being moved around? So today our main focus is going to be translations. Translations, if you've forgotten from Algebra 1, I think you do it a little bit in geometry too, but it's been a while since I taught it. We did when I taught it at least. So translations are a type of transformation. So transformation, big picture, translation, type. It moves your graph or shifts your graph. Instead of saying graph, let's say shifts your function left or right, or up and down, or and, or. And it's called a translation. So let's talk about how that affects the equation. So these are the parents. The next form of the equation is called vertex form. If you remember vertex form of a quadratic is f of x equals parentheses x minus h squared plus k. Don't forget your squared. A lot of students accidentally drop it. And then an absolute value looks very similar. Is f of x equals the absolute value of x minus h plus k. Now I'm writing these together because they affect the equations the exact same way. So the h value, that translates your function horizontally. So that's going to be going left or right. If in the parentheses it's plus h, it translates left. If it's minus h, it translates right. So it's the opposite of what you would think. Then we have k on the outside, and k translates vertically. So plus k goes up, just like you would think, and minus k goes down. So the other thing that's kind of odd is these go the opposite way. Basically anything in parentheses or inside the absolute value is going to go the opposite way, but we'll talk about that more soon. Now, it's called vertex form because it's moving your vertex left or right and up or down. So you always know your vertex will always be h, comma, k. So whatever the h value is and whatever the k value is. And we will talk about that more. So let's do an example of just listing the transformations and writing the equation. Or not the equation, sorry, vertex. So, example, list the transformations and vertex of the function let's do g of x equals x plus 7 squared minus 14. Okay. So transformations, we look inside and on the outside. So this plus 7, hopefully you're thinking, well, that is a translation and it's horizontal. And because it's plus 7, that means we're going left. So one transformation is translate. This is translated left 7. And it's also translated down 14. You must say translated and the direction and the number. You're not going to say translated plus 17. You're not going to say translated minus 14. I want you to make sure you're using the right vocab. So then the vertex is going to be left 7, so it's going to be at negative 7 and down 14. Negative 14. Okay, let's do another example and then we'll do a graph. Alright. Describe the transformation. Actually, let's just graph it. And graph. Okay. Let's do an absolute value function. So let's do j of x. Oops, that's okay. J of x equals the absolute value of x minus 1 plus 3. So first of all, let's describe the transformations. And I'm just going to do this, well, I guess I'll keep color coding. So this minus 1 means we're going to be translated, translate right 1. And then this plus 3 means we're going to translate up 3. So to graph it, we can start by thinking about the parent function. So remember, the parent function is y equals the absolute value of x. And make a table. So maybe you remember this from Algebra 1. If not, that's okay. But we want to have 5 key points so that we have the vertex in the middle, and then 2 points to the left and 2 points to the right. So for the absolute value, That's going to be -2, -1, 0, 1, and 2, because the origin is the vertex. So to figure out the y values, you can just substitute it in. So it's going to be absolute value of -2 is 2, absolute value of -1 is 1, 0, 1, and 2. Now, this is the parent. We want to graph the new function. So to do that, we can look at how it's been translated. Because it's been translated right 1, that means that all of these are going to be moved right. So we're going to take all of them, we're going to add 1. So -2 plus 1 is -1. -1 plus 1 is 0. 0 plus 1, 1 plus 1, and 2 plus 1. Then for our y values, we can extend our table. And these are going up 3. So I can rewrite this as y plus 3. So 2 plus 3, 1 plus 3, 0 plus 3, 1 plus 3, and 2 plus 3. And then these points are going to be the points that I graph. So just for this example, I'd like us to also plot the parent, and then we can kind of tell how big to make a graph. So we're going to want our x values to go up to +3 and our y values to go up to +5. So I'm going to go up to 5. And I always like to make a full graph. And then I'm going to go to -3 and +3. And I'm getting these values from here. So the parent is going to be this equation and these values. So -2, 2, -1, 1, 0, 0, 1, 1, 2, 2. And if you remember from Algebra 1, this is completely straight. And be very careful that you line this up perfectly, or else your graph could be wrong. Okay. Now my transformed function, so -1, 5. 0, 4, 1, 3, 2, 4, and 3, 5. And then I'll connect these very similarly, so it makes a little V. And then you can see this has been transformed right 1, up 1, 2, 3. And then each one has been translated that way. So normally you just need to graph your j of x function. So this is the transformed function. So that's it. We'll practice more of this in class. And if you wanted to, you could confirm this with a graph using Desmos. I could even show you how to do it real quick here. So if you want to stick around. So I'm going to take a graphing calculator. I'm going to press y equals, and I'm going to graph the parent first. So absolute value, I'm going to press math, go over to number, and then absolute value, and then x. So there's my absolute value of x function. If I go back to y equals, I'm going to do the absolute value of x minus 1 plus 3. So math again, number, absolute value, x minus 1, go to the outside, plus 3. Hit graph, and then we'll confirm. So going right 1, up 3.